In this video, we're going to look at how to solve trig identities. And what's going to happen here is we're going to have some kind of equation. We're going to have some trig stuff is equal to some other trig stuff. And our goal is to work with one side and get it to look like the other side. So we say two functions are identically equal if they are exactly equal to each other for every x value. And that's what we're going to do. Now we're going to use all the different identities that we have developed up to this point in the course. So tangents equal to sine over cosine, cotangents equal to cosine over sine, cosecants equal to 1 over sine, secants equal to 1 over cosine, cotangents equal to 1 over tangent. And then we've got our Pythagorean identity, sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared, and cotangent squared plus 1 is equal to cosecant squared. And then we've got all of our even odd properties that we can use as well. So this is our toolbox of things that we can dip into to take and solve a trig identity. So we always work with one side of the equation. Typically, you want to start with the most complicated side. And then we're just going to try to rewrite it and make it look like the other side. So let's look at a few examples. So the first one, number 19, we got cosecant times cosine is equal to cotangent. So I'm going to leave this right-hand side alone. And I'm just going to draw an arrow through it because I'm not touching it at all. And I'm going to work with that left-hand side because it's the more complicated side. So we could rewrite cosecant as 1 over sine. So that was what we did. We rewrote cosecant and theta. And then we're going to multiply. So 1 over sine times cosine is cosine over sine. And then we're going to use that trig identity that cosine over sine is equal to cotangent of theta. And that right-hand side, I just drew an arrow through there because it is cotangent. I'm not messing with that right-hand side. I worked strictly with the left-hand side. And then we'll just call that definition of cotangent. That was our third step. And you stop once you get the same thing that's on the other side. Let's look at another one. We've got secant to the fourth of theta minus secant squared theta is equal to tangent to the fourth of theta plus tangent squared of theta. We're trying to prove that. And with a proof, we're going to look at one side of the equation. So I'm going to leave the right-hand side alone, and I'm going to work with the left-hand side. We certainly could try it the other way. There's not a more complicated side on this side. So you just pick the one you want to start with and see what happens. So I see that I could factor out a secant squared. And that's going to leave me with secant squared of theta minus 1. So I'll write the steps over here again. So we factored out a secant squared. And then now we're going to use some properties here. We're going to use the Pythagorean theorem that ties secant and tangent together. We know that tangent squared of theta plus 1 is equal to secant squared. So I'm going to use that substitution right here. So secant squared is equal to tangent squared of theta plus 1. And then I'm going to do a rewrite of that for that second piece. So this means that tangent squared of theta is equal to secant squared of theta minus 1, just rewriting that Pythagorean identity. And then we see we can make that substitution here for tangent squared of theta. And then I'm just going to FOIL. So we're going to have tangent to the fourth of theta plus tangent squared of theta. And that's exactly what we wanted on that right-hand side. So we're done. So with the last two, we started by just making a substitution. This one's going to use a trick. So the more complicated side to me looks like that right-hand side. So I'm going to leave that left-hand side alone. I'm just going to draw an arrow through it so we're not tempted to mess with it. We're going to start by multiplying by the conjugate here. 1 minus cosine of u. What I do to the bottom of the fraction, I can do to the top. Okay, so what we're really doing is multiplying by 1. We're just doing it in a clever way. Now, the reason I would do that, there's nothing I can substitute in for just sine and just cosine. I don't have something squared or anything like that. So this is a trick that we can try. So there's a new trick in our tool belt. So when I do that, I'm going to have sine of u times 1 minus cosine of u over, and then remember, we're going to have to multiply these together. 1 plus cosine of u times 1 minus cosine of u. So I'm going to distribute. So sine of u minus sine u cosine u. And then when I FOIL the bottom, I get fronts, outsides, insides, and last. And then we're going to simplify this. So we have sine of u minus sine of u cosine of u over 1 minus cosine squared of u. So that was a simplify step. Now we're going to use a Pythagorean identity. We know that sine squared plus cosine squared is equal to 1. And we can use that denominator. If I tweak this Pythagorean identity by moving that cosine squared over, I see sine squared is equal to 1 minus cosine squared. So I can make that substitution for that denominator. So I have sine of u minus sine of u cosine of u over sine squared of u. Okay, so another trick we're going to add to our toolbox is splitting a numerator. Okay, what that means is I'm going to split the numerator into 2 pieces. Okay, so what you're really doing when you split a numerator is undoing fraction addition. Remember, to add fractions, you got to have a common denominator. So if we wanted to put these together, we would get this step. Splitting the numerator is undoing that addition. And then now we can simplify this. So sine u over sine squared of u is 1 over sine of u. And then sine u cosine u over sine squared u reduces to cosine of u over sine of u. And then that, I'll write it over here, is equal to cosecant of u minus cotan of u. And that's what we wanted over here on the left-hand side. Cosecant of u minus cotan of u. So we've got the same thing on both sides. We have solved that trig identity, but we've added 2 new tools in our toolkit. We multiplied by a conjugate here, and we split the numerator. So those are tricks that if you're not sure where to start, see if you can use one of those. So let's do one more. Looking at 49, the left-hand side is more complicated, so we're going to work with it. So I'm going to draw an arrow down the right-hand side. I'm going to start by adding the fractions. I need a common denominator. My common denominator is going to be cosine v times 1 minus sine v. So I'm going to multiply that first fraction by 1 minus sine v. And I'm going to multiply the second fraction by cosine of v. And that's going to give me that common denominator. So let's multiply everything out. I'm going to have 1 minus 2 sine of v plus sine squared v. And then cosine times cosine is cosine squared v. All over. And I'm going to leave the bottom factored in hopes that we'll be able to simplify it because the right-hand side is just 2 secant v. So at some point, we've got to be able to get rid of it. So first step we did was added the fractions. The second thing that we did was distribute or multiply. So now check this out. We've got a sine squared plus cosine squared here, and we know we can use the Pythagorean identity. So Pythagorean identity, sine squared plus cosine squared is equal to 1. So we're going to make that substitution there. And that's all over cosine of v times 1 minus sine of v. So 1 plus 1 is 2. So we have 2 minus 2 sine of v over cosine of v times 1 minus sine of v. I'm going to keep my arrow. So simplify. And then notice we could factor a 2 out of the top. That's going to leave us with 1 minus sine of v. And check this out. We have a 1 minus sine v in the top and a 1 minus sine of v in the bottom. So they're going to cancel. So we're going to have 2 over cosine of v, which is 2 times secant of v. And that's what we wanted. We factored, we reduced, and then we used the identity 1 over cosine of v is equal to secant of v.